Hi everyone, good evening and welcome for my talk today. Before I start, a bit of intro about me. I'm Chetan Raghuprasad. I work as a threat researcher at SugarGh0st and I'm based in Singapore. And my research focus, I love to work on crimewares and ransomwares in my day-to-day activities. So in today's talk is about SugarGh0st RAT, and morning we saw a glimpse of it which relates to another espionage group which was doing the campaigns, and there was a overlapping. So in this talk today I will take you through. First we will see what the SugarGh0st RAT is and what are its features and functionalities, and how it is different from the previous versions of Gh0st RAT, and what are the modifications that the threat actors have done in this variant. And then we will see some campaigns that the threat actors are doing by employing this SugarGh0st RAT, targeting government institutions as well as other users, with the techniques that they have used to implant this SugarGh0st RAT in a victim's machine. So let's start with SugarGh0st. SugarGh0st RAT is actually the customized variant of Gh0st RAT that we discovered in the month of November last year while analyzing a campaign. And we saw that and we suspected that a Chinese-speaking threat actor is operating this campaign, and they are operating as early as sometime around August 2023. And we also discovered two typical infection chains that the threat actor was using, and they were multi-stage infection chains that we're going to see later. And then this SugarGh0st RAT used some of the customized commands to facilitate remote administration, to do some remote administration operations that are directed by the C2, as well as it has some modified communications protocol in this variant that we saw. If we talk about SugarGh0st functionalities, so it has various similarities when we compared with the previous version of Gh0st RATs that are flying in the threat landscape, including taking full remote control of the victim's machine, as well as enabling key logging or hooking to the webcams, or capturing the screenshots and creating a zip archive of that and exfiltrate those screenshots, and also some of the capabilities to run arbitrary commands or binaries on the victim's machine. But the customized features or the changes that we observed in terms of conducting reconnaissance on the victim's machines, as in some new techniques that they have include in checking some specific registry keys that are related to the ODBC configurations of the database. And also they were trying to load some library files that are arbitrary library files with the extension .lib during their runtime. So these are some of the new modifications that we have seen in these samples, as well as another major observations that we saw is with the C2 communication protocol. In the previous versions of SugarGh0st RAT, it has a pattern with which the network packet, the first 5 bytes were reserved with some 2 bytes characters, I would say. Like previously we have seen they've used characters like ghost or some various other characters of 5 bytes. But in this variant we saw that they have reserved first 8 bytes in the network packet header as their communications marker maybe, or as the C2 side if they want to detect those network packets that are generating from these SugarGh0st RAT variants. Then with the key logging functionality, which we observed that during its runtime, like once it gets initializes, that it attempts to create the directory winrar, as well as it tries to write all the keystrokes into a winlog.txt file. And after that, later it will attempt to zip that file and exfiltrate over the network in the chunks of bytes. And with respect to C2 communication, they have used WSA startup functions to connect to the C2 that were hard-coded in the binary that we observed. And this is one of the C2 which we observed in the sample, and we got to hunt for other two C2s that these SugarGh0st RATs were using. And interestingly, morning we had a question from one of the audience that what these threat actors will do after the things are published or after you disclose their activities in the blog post. But interestingly here, the first C2, which starts from login.drive-google.com.tk. So this C2 is still active. So even after we published a post and after several months, this C2 is still active, and some of the samples are still beaconing or communicating to this C2. And recently, the third C2 which we saw, which was spun up in April, I think, in the end of April, is the observation which we saw. That's a new C2 that they have added into their cluster. So we are constantly tracking their activities and trying to see what other new stuff that will appear from them. And the SugarGh0st RAT also has the capability to manipulate the victim's processes and services, that they gets the configuration files of the running services or processes and manipulates those services by either they can terminate those services or delete those targeted service during their runtime or during the time they are initializing. And then we have also seen that these SugarGh0st RAT can delete the event logs from the victim's machine to hide from the analyst or to hide from the detection methodologies which we have. And they can access those event logs or the machine's application logs, security logs, or the system event logs, and can delete them. And I was telling about the modified communications protocol and about the bytes that they have assigned with this new variant was the 8-byte header. So this is one of the sample network packet that we captured and we analyzed while we are doing the research. And we found that that's the first 8 bytes they are reserving, they're using it as a heartbeat. So the first packet will be sent to the C2 server and will get the response, and once this connection is successful and established, then they will start attempting to send more other data that they have done the reconnaissance on the victim's machines, like including computer name and root, as well as the other drive information, as well as it also tries to look for those ODBC keys under software hive if it is present on the victim's machine. And they are using 2 campaign codes that we analyzed. So one of which is in the format like month and year, and another code in the variant which we analyzed was default. But they are trying to use different campaign codes in their other samples that we have also seen. And also, along with these campaign codes, they are also exfiltrating or trying to send the Windows version number of the victim's machine, and as well as volume serial number of the victim's drive. So this is one of the example to show that the SugarGh0st RAT's capability or the modified feature at the network communication level to its C2. Then we talked about some of the commands that it facilitates. So this has the capability to execute or to facilitate the commands that are directed by the C2 to the SugarGh0st RAT, that the C2 will send 4 bytes hexadecimal commands, which has got its own features and functionalities. The commands list was extensive, and I have captured some of those interesting commands to show here in these presentations, where you can see they can adjust the shutdown privileges on the victim's machines, as well as to clear the event logs, or to control the mouse activities on the victim's machine, and then to send or receive the files from the C2 servers. And also it includes like terminating the process or enumerating the process informations on the victim's machines. So these commands were hard-coded in the SugarGh0st RAT binaries, that as and when it receives as a response from the C2, that it will look for the specific commands, and the specific case in the binary gets executed to do that defined functionality in the RAT. So far we saw its features and its functionalities and how it works. And now we'll take a look at the campaigns that we have analyzed by the threat actors using the SugarGh0st. The first campaign that we analyzed, that the threat actors were likely targeting Ministry of Foreign Affairs in Uzbekistan. And we found this by analyzing the contents of the decoy document that they have used in their attack chain. And that decoy document had contents in Uzbek language. And we tried to drill down, and finally we found that it's about a presidential decree in Uzbekistan, like focusing, enhancing state administration technical regulation. And these contents were published in a couple of Uzbekistan websites where the attacker might have used those contents to create the decoy document. And another campaign that we analyzed was targeting users in South Korea. They were using some decoy documents that were related to some Microsoft account security notifications, or with the contents related to some news from CoinDesk Korea, and also another one with the instructions for computer maintenance for the users. And also, not only from the language of the decoy documents with respect to South Korean users, we also see that some of the nodes or the IPs that were trying to resolve the SugarGh0st RAT C2 servers while doing our analysis. So that made us to decide that they might be targeting the South Korean users as well. So with this, now we'll see in these campaigns what are the infection flow or the attack chains that they had employed in their attacks. So I had mentioned that they were like multi-stage attack chain, and they had used multiple components in their attacks, which we will see. So the first infection chain, so here we saw that the initial vector was a RAR file attachment that was likely sent through a phishing email to the user. And when the user opens, it had a Windows shortcut file, the LNK file. And when they run the LNK file drops a JavaScript on the victim's machine, and that JavaScript detonates a couple of activities. It's a huge JavaScript that we identified, and it has like lots of base64 encoded binaries, which was there in the JavaScript file. And when it runs on the victim's machine, that it drops a couple of components that were a decoy document and another batch file, and then another loader DLL with the name msa.docg.dll, and an encrypted file with the name dplay.lib. So once that has been dropped, and the next thing what this JavaScript file did was it initiated or it executed the batch file that it dropped. So when the batch file ran, so that batch file had some instruction to start this loader DLL, that it loads that into the memory and it runs the loader DLL and executes its function, which loads this encrypted file called dplay.lib and decrypted that, and then it injected into run.dll.32 process reflectively, which is actually the decrypted SugarGh0st RAT, and that it starts communicating with the C2. So this is the first infection chain that we observed in one of the campaign. And if we take a closer look at some of its interesting components, the first one was the link file. So this LNK file, when we analyzed, we saw that it's fairly uncommon to see a script that has been embedded in the commands arguments of the link file. So the attacker is having a script here. So what it does is, when the link file runs, the script will try to load the LNK file again into memory and try to look for a marker which is var onm equals. And if it finds the marker, then it writes all the bytes after that marker into a JavaScript file in the temp location of the victim's machine. And then it executes that JavaScript file that it drops using cscript lolbin. And when this JavaScript runs, like I said, it tries to do a lot of activities. So firstly, that it decodes and drops a batch file, and then it also subsequently drops those DLL loader and encrypted file, as well as the decoy document into the temp location that we saw in the infection chain. And also it does some other activities, like it copies run DLL32 legitimate executable from the Windows subsystem folder to the temp location. And finally, it executes the batch script that it has dropped in the temp location. And when the batch script runs, and you can see the command there below within the batch script, that it executes the dropped DLL file using run DLL32 and executes its function, DLL unregister server, which is a malicious function. And we will see now what this MSA docg.dll do, or that malicious DLL component of this attack will do. Actually, this DLL is a 32-bit library, and which was written in C++, and this was seen compiled in the month of August last year. And this is actually a packed DLL, and which has its own custom unpacker code in it. So when the DLL unregister server function got executed, it executes the unpacker function and unpacks the DLL in the memory. And after it unpacks, it will look for this encrypted file with the name dplay.lib. And once it finds that, it loads that file and then do the decryption of that file. And the decrypted file in memory is the SugarGh0st RAT variant, which it injects into the process reflectively and runs the SugarGh0st payload. So this is about the first infection chain that we observed and the technique that they have used to implant this SugarGh0st RAT on victim's machine. So the second infection chain, initial vectors and the technique looks somewhat similar, that through RAR files as well as through LNK that they drop the JavaScript file. But within the JavaScript file, the activities and actions or the other components or the technique differed from the previous infection chain. So here, when the JavaScript runs, so initially it dropped a decoy document and another legitimate DLL file, which is called DynamixWrapperX DLL, and then an encrypted payload that it dropped. So along with that, it first copied the executable wscript.exe, which usually used to execute the Visual Basic scripts in Windows, and it copies to the temp folder masquerading as with the file name dllhost.exe. And after that, it created a run registry key called ctfmon.exe by configuring the path of those executable in order to establish the persistence. So here, one thing that they did is after doing these first two activities, it opened the decoy document on the victim's machine. And then, similar to the previous attack chain, here they are using a legitimate component called DynamixWrapperX DLL file. So this is actually an ActiveX object tool, and what this tool does is it helps to execute ActiveX components which are in the JavaScript or VB scripts. So the attacker is trying to abuse this feature in this campaign. So what they does is they first install this DynamixWrapperX.dll on the victim's machine. That they load that into memory through Gh0st as well as they attempt to create the registry keys in the software highs with a specific class IDs. And then afterwards, this DynamixWrapperX.dll, they load this encrypted payload, that libeay30.lib, which is the encrypted file which it dropped. And the DLL component had executed a shellcode which was there in the JavaScript file. So using the help of DLL-wrapperX functions that was loaded into the memory, the ActiveX components in the JavaScript file executed the shellcode, and that shellcode loaded this encrypted file, decrypted it, and then it injected reflectively into the dllhost.exe service which it was running. So if we take a look at the shellcode, how it does is that it has all the API hashes and instructions to load from the kernel32.dll, which required for the injection process, as well as it loads two other DLL as well, like user32 as well as SHLW API. And then it tries to look for this .lib file, and it loaded into the memory, and then it decrypts it and reflects it into the process which we saw, that dllhost.exe process, and communicates to the C2. So apart from these two infection chain, recently we saw another infection chain which has slightly different initial vector, where previously we saw the RAR file which has a LNK, and that dropped the JavaScript file. But here in this infection chain, the initial vector was an SFX RAR executable which had an SFX script that dropped a VB script on the temp folder along with the other components. And here if you see the auth.z.lib is the encrypted SugarGh0st, and update.dll is the malicious DLL which loads this auth.lib, and it had a shellcode which attempts to decrypt this auth.lib.zip and injects it into process. And the VB script that they are using in this attack in order to establish the persistence to the registry key, user init logon script registry key actually. So once it deployed, and whenever the user tries to log into the victim, or the victim tries to log into their machine, so this update.dll will start to execute. So these are the three infection chains so far that we have seen with this actor doing or targeting victims across the world, and we are continuously monitoring their activities and trying to see the new things or the new techniques that they are incorporating in their attacks. So lastly, before I conclude, we did see several indications while doing our research which allowed us to suspect that a Chinese-speaking actor is operating this campaign using SugarGh0st. Based on one thing was analyzing the metadata of the decoy documents. So it had the last modified names which are in simplified Chinese, as well as the Gh0st RAT malware is the mainstay of many Chinese threat actors, and it has been active since at least 2008. And then also the Chinese threat actors have a history of targeting Uzbekistan. So this allowed us to assess with, at the time of our research, we assessed with the low confidence that the Chinese-speaking actor is conducting these operations, as well as we also see one of the language that the example which I showed with the SFX star has a comment in simplified Chinese. But from the morning session, so that added more confidence to our suspicion about a Chinese-speaking actor, that they disclosed and they have found several overlaps in their infrastructure of many Chinese actors. So it is open to conduct further research. So we are continuously monitoring and trying to see what other things that we can find in this. So with that being said, I'm concluding my talk today. So if you have any questions. Thank you everyone for your attention. And thanks SynCon for having me here today.